Hi. Hi. Can you hear me well? Yeah, okay. Hi, my name is Ziv. I am a front-end developer at WIX, working on an awesome product called the WIX Code. What I'm going to talk about today is how to handle error reporting, especially in an environment where your application might be running along with other applications, whether it's on the same web worker on the same browser frame. I'm very excited to be here, so let's break the ice a little bit. Let me tell you about myself. So who am I? I'm, well, too much. I'm volunteering as a paramedic, first responder, 24/7, trying to save some lives around me on different kind of medical incidents. I'm also a DJ. This picture was taken actually last week at the Proud events in Tel Aviv. Yay. And I love street art, so if you know street art in Riga, please feel free to approach me and take me there. Yeah. So, let's go back to our reporting. Why should we even care and want to report our errors in our software? Who recognizes this screen, this prompt? Yeah, many of you. This prompt asks the user to, something went wrong, please report this error for us. So what I want to say that first of all, when we are dealing with error reporting, if the user is the one that reports the error, either by clicking that prompt or by calling the customer support center, that means many other users hit the same issue and they didn't even reported it. They just silently left your application without you knowing why and etc. More than that, users tend to use our software differently than what we designed it. So sometimes it is because lack of documentation, sometimes the user really don't know what they are doing, and it's okay, but we can spot those trends also by reporting the errors the user are creating in our application. We can better test our application if we have an error reporting system in which for each kind of error that we fix, we can build a test, especially if we are working with the TDD methodology. We can build a test to reproduce that error and make sure, put our fix, and by that make sure this error won't come again later on. And all in all, this will lead to a better user experience because many of the errors that are being reported are pretty much like null pointer errors or undefined variables errors, and those stuff can be easily fixed, and it makes the user feels that someone is behind this system, someone is behind this software, fixing this error for him, monitors those errors, and your user will be much happier to come again to use your software, to use your application when they notice that. So we at WIX had a problem with error reporting. And we will use WIX Code, my own product. I mean, not my own, but where I'm working, as the... sorry for that. I think the clicker drank too much coffee this morning. So we will use WIX Code as our use case. So WIX Code is a great new platform that empowers our site builders of Wix and gives them the opportunity and the ability to actually write their own code and creating from just normal sites to actual web applications with dynamic pages, with some logic running on the front end, on the back end. They can manage databases and etc. Really modern development environment. And the thing is that, oh, and by the way, we are using Sentry as our error reporting system. It's an external tool that we use, third party, open source, very nice. This is how we see the error reports. We get a list of errors, what happened, on how many users it affects, and etc. So the thing, so we divide our scopes, our our focus to two main ones. First of all is our own code that the user that is being operated by the normal user stuff, like he can configure data binding with the databases and configure actions and interact with the APIs. And this is our own code. The thing is that the user is able to write his own code, and there's another main concern that we have. Now, consider that our users are not always coders like us. Some of them are designers, some of them don't have any JavaScript knowledge prior to what they see in WIX code. And even if they are coders, imagine yourself when you're coding something, how many times do you just run and trial and error, and you run your application and you see, oh, damn it, I forgot this one, and you encounter compilation issues, you encounter null pointer issues, stuff like that. So when they do that, we get the report. Let's visualize it. So if this is their code and it is being run within our code, so eventually if they have an error, it will throw an error to our Sentry, to our error reporting system. So at first, we wasn't that worried about it. We went with alpha users, and we didn't have that much errors. So from time to time, a certain developer on the team took one for the team and went to Sentry to filter out all those user errors. But as we became beta and more users joined WIX code, so we ended up with thousands of errors being reported every day, and it was unmanageable, and a developer cannot sit all day and filter out user code. It will take forever, and we had to do something with it. So this is where I got the task of building something that we can differentiate our errors and our user errors. So we needed to find a way of how to differentiate the errors, and when we do, and we know which kind of error comes from where, what shall we do with it? We can either report it to another system, we can ignore it, we can do different kind of stuff, but the first task was to actually bound those errors. So we need an error boundaries, of course. We started to came up with ideas. First idea, very intuitive, was let's duplicate the class. Okay, we have an API. The API, we are externalized, we are exposing it to the user. Let's take this API, duplicate the class. We push that class to the user, and we know exactly when the user is, when exactly those functions in this class are running. But the thing is that code duplication, well, it smells, right? We are engineers. We know that where we see duplicated code, it's not a good sign. And we didn't want to go there. Even more than that, the application package size might be even bigger and bigger as we duplicated more and more classes. And in WIX code, we have a lot of API. By the way, part of them are not even in our code base. So how can I come to another WIX development team and say to him, well, dear team, please duplicate the class and have your engineering hell and good luck. The other thing that we thought about is maybe we can somehow flag a function. Let's see how it looks like. So if we have this API object with those two methods or more, we can run something like load-map values on the API object, and for each function, we will add a flag on that function and return f. And eventually, we will return this external API. And when you think about this kind of solution, what do you think? Well, this is very hacky, right? I mean, yeah, it's JavaScript, and we can do everything in JavaScript, but it's very hacky, and I think it's also a little bit ugly. If any one of you did something like that before, by raising hand? Just one hand. Please come to me after this talk. Anyway, the thing is that more than that, hacky and ugly code is contagious, and we don't want that either. And finally, we ended up with scoping. So what we wanted to do is scope each one of the runnable areas in our code. For example, WIX code, the user code, maybe some other application at WIX code, and let's see how it is being done. So we call the solution arrow boundaries. The arrow boundaries function gets a list of scopes and an error handler. What it does is basically build a map of boundaries and return it. The way we build this map is that we iterate over the scopes, and for each scope we add the scope name to the boundary and calling the error scoping factory with the scope and with the error handler. Let's go over scoping factory. So scoping factory is a factory function that gets the scope and the error handler. It's responsible to run the actual function that needs to be run, that has been called either by WIX code or either by the user, and save the result and return it. In case something goes wrong with all of this scenario, then we call the error handler with the exception and the scope. So the error handler is the function that gets where the error and the scope and decides the user, the consumer of this error boundary, can decide what to do with it. Like, this error happened in this scope. What do you like to do? You want to ignore it? You want to report it? Anything, all logic such that will be here. Last thing is that we need to check if the function that is running returns the promise, okay? Because if it returns the promise, then it won't be caught as part of the try-catch clause. We have to return that promise after we made sure to catch any rejections from that promise and return the promise object as well, okay? And here, of course, we are catching the rejection and do the same with the error handler. So the next thing is that, okay, we have a great solution, great design. We need to test it somehow. We need to test it mostly because we are working in TDD at WIX, and it's very important to us that every single thing we ship to the product is well tested. More than that, since it's very infrastructure, low-level stuff, we want to make sure that this thing won't break any other logic or functionality. So testing this kind of buggy and error-y cases is very challenging. First of all, we had to simulate a bug in WIX code. So WIX code has a lot of APIs, and we had to test all of them, each one of them. The thing is that how do you usually test buggy and rainy day scenarios? We probably will use stubbing, right? But the thing with stubbing is that it replaces the function. So if the function that I want to test, if the API that I want to test is wrapped with error boundaries, if I use stabbing, it actually overrides the arrow boundaries wrapping. Okay? Make sense? Okay. So this is problem number 1. Problem number 2 is that we had to actually look for bugs in WIX code because we cannot use stabbing. So we had to think of buggy scenarios. But it's a paradox because if I can know of a buggy scenario, then I will have to fix it and not using it for testing purposes. So it was like a loop, endless loop of, okay, maybe we can do something like that. Oh, it's a bug. Okay, let's open a GR ticket, fix that. Oh, maybe you can do this. I don't know. It was very messy, and eventually we ended up with writing. Well, we actually succeeded in stabbing maybe third parties functions. We even build more proxies and facade classes just so we can, stab there, or even ended up with intervening the application state. We are using Redux. So we intervene in the Redux state to make it faulty, and for each part of each one of the APIs will somehow cause a faulty state in the Redux and will cause the application to crash. Again, for each kind of API, we wanted to test it whether it comes from the user code and when it comes from our own calling. The second thing is that we need to intercept the reported data. Okay, so we are testing error boundaries, and as I mentioned, we are testing both sides of user code and our own application code. And we wanted to make sure that when we are reporting something, it is the correct report. I mean, the correct report is like this and this happened with this scope, and the stack trace is this and that, and etc. And we are using Sentry, and we started to look for solutions with Sentry of how we can do something like that, how we can inspect the reported data before it is being sent to Sentry. And more than that, we didn't want to send reports to Sentry for testing, right? So at first we thought about maybe building a proxy server that when we are running tests, the server will start up and will intercept all the Sentry HTTP calls. And by that we can get the call, block the calls from being sent elsewhere from Sentry, and to Sentry, sorry. And eventually we will get the data. We'll get the HTTP request, and the data comes with it. The thing is, also here, it's very heavy, okay? Imagine yourself that each developer in the team, each time when he wants to run some tests to make sure that his code didn't break anything, he will have to start up this proxy server, run all the tests, and it's very heavy, and we wanted our test to be faster than that. So what we did is that we found a way, we started to look for a way in Raven, which Raven is, by the way, Sentry's SDK, is their JavaScript SDK. So we started to look for a way within Raven how to operate their thing under the hood. And finally, we found a transport layer that can actually be set by a normal API of Raven. And by overwriting this transport layer, well, it has been probably done because if you want to add another transport layer of yourself, like sending it to another system, sending it to somewhere else, somehow intervene with the transport layer with the HTTP request, maybe put some more headers or cookies, stuff like that. So we actually use that transport layer to take over the report. The way we do that is that the module, we call it Raven Test Kit, is getting the Raven instance that is being used by the application for reporting. We are holding a local reports list, an array, and what we do is that we call the Raven with this API, and for each report, what we do is just pushing the report data. This is the data that Sentry holds, the another data of what was the error, what is the message, what is the stack, stack frame, what is the timestamp, and more tagging that can be set by Raven. And what we do is we just push it to the reports, to the local reports variable, okay? And that's it. We don't do anything else. Usually what we should have been doing here is that adding, like calling super or calling some our HTTP post call. And that's it. We return the API. And by that, we are actually eliminating the ability of Raven to send reports elsewhere. And we have the reports locally holded in our memory. So we can now use it to examine the report data and to make all of our expectations and assertions in the test to make sure that from this scenario, that and that error was reported with this scope and etc. So let's sum up. We've been speaking about how important it is to make an error, to have an error reporting system in our application. I introduced you a problem of, well, sometimes we have different kind of errors that are not our own errors, whether you're running in multi-application environment, whether you're using third parties, and you want to differentiate between those errors and your errors. And I presented to you the error boundary solution that allows you to do this scoping and differentiation, and you can pass your own logic of how to deal with those errors. And finally, we learned about the Raven test kit of how we can eliminate the sending the reports elsewhere. We can run tests while being offline, which is very important. It works very fast and it's very easy to maintain. It actually was that good solution, so Sentry used that in their own official documentation and recommending this as the best practice of how to use testing with Raven, which is made us very proud in the team. And that's it. Thank you for being here. I have some time for a question. By the way, WIX Engineering is hiring in Vilnius. If you'd like, come speak at us. Questions?
I didn't saw any on Twitter. Somebody in the room have a question? Anyone? Don't be shy.
Okay.
No, so.
Thank you.